Does anyone know what Newton's third law is? The equation. That's the second law. What? Derek, you said something?
Does it have to do with explosions?
Nope.
And no.
Acceleration. That's the second law. Nope. That's just an observation. That's a gravity thing.
What comes up stays up and later comes down?
Nope. Newton's third law. Sometimes abbreviated N3. If you guys ever see me write N1 or N2 or N3, that means Newton's first, second, or third law. Okay, so Newton's third law. Every action has an, not just a reaction, but an equal and opposite reaction. What? A consequence. Well, some people like to apply this to social situations and say every action is equal and opposite reaction. You know, so Julian, when his buddy calls him a bad name, he calls him one back, right? We've all been there before, right? Okay. This does not govern social situations. This just governs objects and interactive forces. Yes. Forgot why? I did. Ever. Thank you. That spelling stuff is difficult.
Come on, Brad.
It happens. It happens. I know. I'm always thinking about other things besides how I'm spelling a word. All right, so every action is an equal and opposite reaction. Okay. Now we have a hard time talking about action. We don't say a lot about action and reaction. We talk about forces, right? So some people might rewrite this as every force has an equal and opposite re-force. Okay. Made a word up there, re-force. Okay. Got quotations around it. So every force has an equal but opposite re-force. I did not come up with it. There's been many times physics teachers have written that down, so it is not my made-up word to claim. Okay. All right. Are there any questions about how I have it written? I know the third law is written. Yes, no. All right. So, the equal and opposite forces, the action force and the reaction force, the force and the re-force, okay? Those form what's called a Newton's third law pair, okay? A Newton's third law pair are forces that are equal and opposite. Okay, you can call it a third law pair. It's also called a action reaction pair. Sometimes I'll put a slash here. Okay. So those are synonymous. Third law pair or, got my or, forgot 2 letters that time. Okay. Third law pair or action reaction pair. All right. Those are 2 forces that are equal and opposite. Okay. 2 forces that are equal and opposite. 2 forces that are equal and opposite. Wow, that E looks really funny. There we go. Okay. So to get started with this third law pair idea.
Wait,
what?
It can only be 2 forces?
Yep.
It can't be more than that?
Nope. A pair means 2. Or a fruit.
I see what you did there.
Nice. You like? I got some chuckles. I know that's P-E-A-R. I can spell fruit. Otherwise, I have a hard time finding pears at the supermarket. All right. That dot tells you I want you to draw what for the book? Was it Stephanie? What? Oh, you said it. A free body diagram, right? So draw a free body diagram for the book, please. Wow, why is that a book? It's a 5 kilogram book. It's a dictionary. Sorry, I forgot to label my book. This is the book. Okay, that's the book right there. Yeah. There's a hand sanitizer right there too. There's hand sanitizer if you need.
I don't know how I'm bleeding.
Okay.
Oh, that's bad.
Put hand sanitizer on and it'll tell you because it'll sting. So draw a free body diagram for my 5 kilogram book. We'll call it Webster's Dictionary. Big version of it. Fully illustrated. Every word has a picture. That'd be a lot bigger than 5 kilograms. Like 10 pounds. Alright, so free body diagram. What force are acting on the book? Gravity. Gravity goes which way? What else? Force normal. Which way is force normal point? Up. Now, how are these two related? They're equal. How do you know they're equal, Kim? Good, it's motionless. No acceleration, so we know Fn equals Fg. Now, here's the question. Are those a third law pair? Kim says yes. In this situation? Anyone else? Are those a third law pair? Richard?
No.
No. Why do you say no?
It's not an action.
What's not an action? Saying a book on a table is not an action? Okay. Notice the action-reaction part is the confusing part. Action-reaction are just words that they initially used. Okay? Is there a force and a reforce? I set the book on the table, normal force is applied, right? So, are those third law pair?
Yeah, maybe.
They're equal and opposite, right? They're not a third law pair. Okay? Common misconception. Students think every single equal and opposite forces are a third law pair. These are not a third law pair. Okay. Why? Because if I were to accelerate this book upward, which one would be bigger? The normal force would be, right? So if I were to take the table and lift it up, the normal force would be bigger. So would they still be equal? No. If I were to cut the legs off the bottom of the table, cut the legs right there, the top of the table is going to fall, right? Which force would be bigger? Gravity. Are they still equal? No. So they're not equal and opposite all the time. They're equal and opposite in this case, but they're not a third law pair because they're not always equal and opposite. To figure out the third law pair, we have to draw another free body diagram. What's that free body diagram look like? Or what's it for? Okay, guess? The table. We already have one for the book. Okay? We have to draw a free body diagram for the table. So, another dot. Draw a free body diagram for the table. Draw a free body diagram for the table. You guys have cracked on my spring scales. Cool. Free body diagram for the table. So forces. What do we got? Gravity. Where's gravity push? Pull. Down. So gravity pulls down. The table weighs more or less than the book? More. So should the force be longer or shorter? Longer. What else is actually on the table? What? A force in the book. Which way does that point? Down. Right? We put a book on the table. Doesn't the book push down on the table? Yeah. So there's got to be a force that goes down from the book. If you don't believe me, take your book and set it in your lap. You feel a force downward, don't you? Even though none of you did it. That's okay. You guys all felt that before, right? So there's a downward force from the book, right? Now, is there any force that's equal to from our previous drawing? Yes, which one, Moses?
Normal force.
The normal force. Okay? The downward force, let me make that a little bit bigger for my table. The downward force from the book on the table is equal to the normal force from the table on the book. What else is acting on the table? Where does that come from? The floor, right? Now, how does the force normal compare to these two forces? They're equal. Okay? So force normal should be the sum of these two, right? So I didn't give myself enough space. That force normal should be equal to the force of the book and the force of gravity acting on the table. Does that make sense? Now, do we think we've identified Newton's third law of pair yet?
No.
My color choices may have helped you. Nope. Ah, I see why you said that. I should just use blue, shouldn't I? Okay. I'll fix my picture, Moses. Okay. Now my color choices help you. Fn from here, right? And F book down here. These two are a third law pair. Okay? Those two are a third law pair. Because regardless of how the table accelerates, those two will equal the same. Because it's the book pushing on the table and the table pushing on the book. Okay? So, Newton's third law of pair, something else I want to add to this. It's not just two forces that are equal and opposite. They also have to act on different objects. And they have to be equal in every situation. Two forces that are equal and opposite in every situation. Okay. Two forces that are equal and opposite in, oh gosh, why do I always forget the Y's?
It's okay. It's silent vowel.
In every situation. Now the big one that's going to help you guys the most is that one. They act on different objects.
So what do you mean by that?
They act on different objects. Initially, when we did the free body diagram for the book, we said force of gravity and force normal. You guys, some of you assume that those are normal, those are a third law pair, right? Right. Some of you assume that these two, force normal and force gravity, were a third law pair, right? Okay. But they act on the same object, right? Okay. Because every action with an equal and opposite reaction, what that says is when one object pushes on another object, that same object pushes back. Okay? So the book pushes down on the table when I set the book on the table, right? So the table pushes back on the book.
So let's say, for example, like I seen the diagram of like a person's on a wheelchair or whatever, and it kicks another person in a wheelchair, and like they both then go back. Is that?
Yep.
Boom.
Yeah. Or we
Got
can make a little less aggressive with kicking. And let's say you and your friend are both on roller skates and you're standing like this, hand to hand, right? If you push on his hands, where does he go?
backwards.
Backwards. Where do you go?
He can't keep his balance. He falls.
Where do you go?
I stay.
No, you don't. No.
I stay up. And
You have your brake on, you do, right? But if you don't have your brake on, you go backwards too.
Oh yeah, no, I'll go back, but I stay up.
It's kind of like the the last question on your guys' pretest, right? The person sitting in the desk chair,
Yeah,
and then kick the other person. Oh, that's what you're thinking. Okay, you said wheelchair.
Well, whatever.
Okay, that's fine.
He's
All right.
straight with you and he kicks him.
Any questions about this Newton's third law pair idea? Are there any other third law pairs that we could draw in this situation? Richard? A rocket. No, I mean just in this situation. The book and the table.
The table and the floor.
Okay, we could draw a free body diagram for the floor, right? But we could also assume that the floor is attached to the. It's a big thing. We all live on it. The earth, right? We can assume the floor is attached to the earth. So over here, let's draw a free body diagram for the earth. Okay. Now there's lots of other forces besides just the one we're going to draw acting on the earth. The sun, the moon, close planets, different interstellar objects. Those all exert forces on the earth. Okay. We're just going to worry about the ones in this situation. Okay. So, what pushes down on the earth? No, because the earth exerts gravity. What pushes down on the earth? Okay, I said we're going to ignore everything else interstellarly. We're just going to think about just the earth, the book, and the table. Okay, I'll add the earth to the picture.
What pushes down on the earth?
Everything on the earth.
Okay, we're just worried about the book, the table, and the earth. What pushes down on the earth in this picture?
The book.
Table.
The table does, right? The table with the book.
Yeah, be more specific.
So this is the force of the table on the earth, right? What is that in a third law pair with?
Yes.
Yes, nice, Richard. What is that in a third law pair with?
Pushing up.
The earth pushing up on what? The table. This vector right here is a third law pair with this vector right here. Okay? This is the table, or the earth pushing on the table, right? This is the table pushing on the earth. So why isn't the earth accelerating downward?
The sun.
The sun, okay. But there's some other forces we can add to the earth, right? And the earth's really huge. Okay? There's some other forces we can add to the earth.
The other side.
Does anyone know what else? Nope, there's not an identical table in Australia. There might be, but not.
Excuse the interruption, but students, if you are going
You
to
are
take
interrupting.
one trip, it is time to leave. Please meet your bus back by the band room. Thank you.
Have fun, Aquinas strippers. Remember, skip all the chemistry lectures, go to all the physics ones. Okay. All right, is there anything else, Richard?
I have a question. Remember when you said that you accelerate the book up so it's not a third law thing?
Yep.
What if you said if you cut the table lengths, it's not a third law thing either?
What would be?
Right?
Well, if I cut the table legs, right, then the earth will no longer be pushing on the table, right? And the table will no longer be pushing on the earth, so then those two forces are now, they're still equal. They're just both zero. So the table legs are still getting pushed up by the earth, and the table legs are still pushing down on the earth then too. Okay. It's a very expensive demonstration. Sorry I didn't do it. You need Chuck Norris quickness. All right. Anything else? Any other equal and opposite forces acting here? That's it? Julian, this is it? Those are all the forces?
See, there's the mantle, crust.
Okay. Now, gravity is a force exerted by the earth, right? It's what causes things to accelerate downward, right, John? But gravity is really a force exerted by any object that has mass. Okay? You guys remember that. Gravity is a force exerted by any object that has mass. Does the book have mass? Yeah. Does the table have mass? Yeah. So, do they exert a force of gravity? A very small force of gravity comparatively, right? But do they exert a force of gravity on the earth? They do. Okay? So, this force of gravity right here And this force of gravity right here, they're both acted from the Earth. The Earth applies that to both the book and the table. The book also applies a force of gravity on the Earth. Which way? Up. So this is the force of gravity from the book. Okay? And the table applies a force of gravity upwards. So that this force should be equal and opposite to that one. And those are a third law pair. It's not upside down. Okay, well,